দেখো যেটা ঘটনা হচ্ছে, আমি যেটা দেখলাম, যেটা তোমায় গিয়ে পড়তে হবে টোটালি, যেটা তোমরা করেছো ধরো অ্যাটেনশন নেটওয়ার্কে, যেটা ফার্স্ট জিনিস সেটা জানতে হবে, দ্যাট ইজ অ্যাবাউট কনভলিউশন। ঠিক আছে, দ্য ফার্স্ট থিং ইজ দ্যাট দ্যাট ইজ দ্য প্রসিডিওর। তুমি যদি এটাতে পেনিট্রেট করতে চাও অ্যাটেনশন মডেলে, ফার্স্ট জানতে হবে কনভলিউশন, দেন convolution actually neural network, that means the mathematics behind that, that is CNN. And then there is a encoder and decoder model, and actually we are rectifying this encoder decoder model, and then attention method that comes, that is the procedure to know. Then you can do the several things. That means in several paper they are discussing the attention model ইউজ করেছে ন্যাচারাল ল্যাঙ্গুয়েজ প্রসেসিং এর ক্ষেত্রে, স্পিচ রেকগনিশন, ইমেজ, হোয়াট এভার বি দ্য থিং। বাট আমাদের যেহেতু এখন সময় নেই, আমরা জাস্ট কনভলিউশন একটু পার্ট দেখে we are going to the attention method, how the equations will come or like that. So the thing is that what we know, the convolution of operations, that means the convolution operations. So what would you think about the convolution operator? That means suppose we are tracking the position of a electron. Okay, suppose we are tracking the position of an aeroplane. Then what will happen? And of course we are tracking by using a, say, laser beam. We are tracking by using a laser beam sensor, and at discrete time interval, and discrete, say, time interval. That means what is the need of convolutions that we discuss? That means if we say that is the that is the position x0, and say this is the position x1, and say this is the position and x2 at time instance say t. That is the position of an aeroplane, and we are just want to track. That means say a aeroplane is going to from Kolkata to Kerala, and we want to track the plane. That means how far now it is from Kolkata. Say it is coming from Kolkata and it is going to some, say, Kerala. And the thing is that at time instance t, we want to find that how far now it is from Kolkata. And then what will happen? Suppose that our sensor, that is happening, that our that sensor, that is noisy. The sensor is noisy. So what will happen if the sensor itself is noisy? That means it is very difficult to predict the actual positions at some time instant. So if we want to predict that, what we have to do to obtain a less noisy estimate, if we want to obtain a less noisy estimate, what we have to do? We would like to average several measurements that we do in your lab experiment. Also what you do, that we are just like to average the several measurement and taking multiple measurement and making average of that. That is the thing that we do. So the more recent measurement are more important, so we would like to take a weighted average. Weighted average ব্যাপারটা আসে কেন? কারণ অফকোর্স আমার তো এরকম অনেকগুলো ইনস্ট্যান্ট আছে, সে 3 equals to 5 minutes, and this is for t minus 5 minutes, this is t minus, say, 5 seconds, and that is the tth instant. So what will happen when you have to make the average? It is always better to take the recent measurement. So that's why we have to incorporate some weight. তার মানে ওয়েট যত যাকে বেশি দেবো সেটা আমার ক্যালকুলেশনে তত বেশি এফেক্ট করবে। লাইকওয়াইজ তুমি মনে করে দেখো যে তোমাদের যখন সিজিপিএ ক্যালকুলেশন হয়, এভরি সাবজেক্ট হ্যাজ সাম ওয়েট ডিপেন্ডিং অন the importance of the subject. So here also you have to give some weight, because you know that more recent measurement, that means more the recent the measurements, more recent measurements are more important, more important. So we would like to take, we would you know like to take a weighted average. We have to like to take the weighted average. So like we rely on recent measurement compared to the old measurement. Like that, T8 instant measurement is more important compared to T minus 5 minutes measurement. So in mathematical notations, say we are interested in the revised estimation of the measurement, and it can be denoted by ST. And what is ST? That means you are interested, you are interested, in the, say, revised estimation, revised estimation of, of the measurement. And ST can be denoted as, you can say A equals to 0 to infinity, and this is T minus A, that is the position of, you are reading the positions that you taken at time instant t, and there is some weight vector. I am denoting like that by using minus A, that is the weighted average of all the previous measurement you have to take. That means this W is nothing but, that is the weighted average, because we are writing this summation sign. So this is nothing but, you can say, weighted average of all the previous measurement, previous measurement you are taken. And this is nothing but, you can say, the previous positions. This is nothing but the positions of the, in that positions of the, you can say, the, say if you measure the particle that you taken at, say, time t, and that can be denoted by x, this, at time instant t. This x is nothing but input, this is nothing but convolution, and this is nothing but filter, or that is nothing but weight. So actually in practical, that means in practice, we have to sum over a small window, that means that is not infinity. So if we say practice, the small window is from, we are just taking the 6 measurement, say that can be written as A equals to 0 to 6, and t minus x, x t minus A, we can write like that. And this weight vector, that means this is a weight array. This weight array is known as filter. That is nothing but filter. This is a one dimension. That means, say if we take that, that is the corresponding filter for that particular purpose. That means if we say the filter is from W naught, W minus 1, that is the weight vectors. That means you can say W3, W4, that W5, and say this is W6. And you can say, if we take this as the input, we can take this as a measurement that we have to take in from that is the corresponding measurements that we take from sensor. Say the measurement that we take, this is x, say 1, say 1.5, 1. And 1.57, 1.60, 1.61, 1.63, 1.67, 1.70, like that. It is going on like that. So the thing is that, and where vector has some value, let's say 0 0.01, 0 0.02, 0 0.03, 0 0.05, 0 0.03, 0 0.04, 0 0.01, like that. So what will happen? That means the output, if we want to measure the value of st, the value of st is nothing but you have to multiply this, you have to multiply this, you have to multiply this, like that. You have to multiply this. If we want to find, say we have to find the measurement at that particular point xt, we want to find the measurement at xt, then what will happen? That at some xt we want to compute st. That means at some xt we say want to compute st. Then you know st is nothing but x6 w0 plus x5 w minus 1 plus x4 w minus 2 plus x3 w minus 3 plus x4 w minus 4, x5 w minus 5, and like that x6 w minus 6. You have to just multiply it, and what you will get, you will just get the thing, say the value of st, say after doing that it will come out, say is something like that. I am not calculating it, that is an approximate value that we calculate. Now the thing is, that means that is called filter, and you know that is input. You are convoluting this filter with this input and you will get this value. So the next time if you want to measure, you know, if you say if you want to measure the value at the next locations, what you have to do? You have to shift the filter. That means you are shifting the filter. This filter will be shifting and you are doing the same thing. That means this filter is shifting. That filter will be shifting and you are multiplying this value with this and you will get the next value xt, say this is 1.56, say I'm just not doing the calculations. So we are just slide the filter over the input and compute the value of st based on the window around xt. That is the thing. So what we are doing, so we are just, you know, slide the filter, we are just slide the filter over the input, and you know we are just compute the value of st based, you know, on the window around xt. So that is done for the, you know, for one dimensional. Of course, can we do the convolutional operations on a 2D input? Yeah, we can do it for the 2D input. And what is the basic 2D inputs? That is nothing but image. We can think about the image as, you know, 2D inputs, because image is nothing but you can think about a 2D inputs. So we have taken an image and maybe it was captured, and I am not very confident about all the pixels that I have captured. So now what we have to do? For any pixels, I want to re-estimate using the neighborhoods. So what we would like to do? We have to introduce a 2D filter. Generally it is a square filter, and what we can write for that, the formula that we can write, that means I class k, this ij, and we can write, I am explaining this, don't worry, but that is actually a square filter. But if this is a n cross n, then we can write like that, j minus b, and this is, you know, kab. That means what I am saying to do, that means you say this is an image, say that is a image like that. Now you know this is a pixels that I want to calculate it. That is nothing but, you know, this is, you know, a pixel, and let this is ij. That means this is nothing but, you know, this is ij entry in the image. That means if you don't know, then you know that image can be written as a matrix. That means a1 01, a02, A03, that should be written. That means this image actually you can convert it into a matrix. So that means if we consider a particular pixel, that means this is an element of this particular matrix. So this is nothing but, you can say, pixels can be represented by ij. That means ij entry of the image. Now what will happen, I am not confident, so I am just I am calculating the neighborhood, and that is nothing but, you can say, if we it may be 4 cross 4, it would be better to represent, say this is a 4 cross 4, and you know I what I want a revised I want a revised estimate of that. So what we have to do? We have just to look at neighborhood. We have to look the neighborhood and neighborhood of this pixels. For that I want to find the estimate pixels. And the thing is that, and each of this weight is associated with them, and I am giving some weight associated with them, and each of this weight is associated, each of this weight is associated with them. So that means in that particular case, I, this is 4 minus 1, 4 minus 1, and this is k 1 1. You just see the formula, I minus a, j minus b, and k a b. That means we are taking, that is 1 1, that is nothing but that is nothing but the weight associated with each neighbor, each neighbor. So just a weighted average of all the neighbors. What I am doing, just the weighted average of all the neighbors, that I doing here, all the neighbors, that is nothing but about 2D pixels. That means in that formula what I am writing here, that means I that I minus a, j minus b. That means we are taking the previous neighbor, because previous neighbor. But the thing is that, so the questions may arise that why not future neighbors? So there are different packages that will use different convolution formulas, but that will looks like we are considering the preceding formula. So in practice we are using the succeeding neighbors. That means this is the preceding neighbors. In formula we can use the succeeding neighbor, like that. If we say we have to compute the Sij, that means that is the corresponding formula, and what we can say, a equals to 0, that is m minus 1, and this is b equals to 0 to n minus 1. We can use like that, ir plus 1, j plus b. That means this is nothing but the weighted average of the succeeding neighbor. So that if we take an example, simple, say what you write, that if this is the input, that is a simple toy example. If we say the input is like a b c d, e f g h, that is I J K L. That is a simple toy example, and this is the kernel. You can say this is kernel, or you can say that is the weight, or you can say that is the filter, whatever be the thing, and say the filter is like that. It is given W X Y Z. Now if we want to find the output, if we want to find the corresponding output, an output that can be represented like this, output is nothing but, you will find the output should be like that. And what I am trying to say, that first what we have to do, uh, you have to multiply this with particular input box is this. That means if we say about the output, it is nothing but AW plus BX plus CY plus FZ. Now what will happen? You have to shift the input. You have to shift the input, that is the next input, and again you have to multiply with this. Then what will happen? Dot product. I'm not wrong. Actually, I have to take the dot product. That means we can write BW plus CX plus FY plus g dx. And again we have to shift like that. If we shift the input like that, then the thing is that cw plus dx plus gy plus hz, and we can compute the rest of the thing, but just moving the input. So we are just sliding the kernel in the next input. We are just sliding, we are just sliding the kernel in the next input. So that is the corresponding, and but the actual formula that we use for the convolutions, that is the center problem, because you will find we are taking the that is the corresponding taking the value that should be multiplied dot product with the kernel. So we are taking from a equals to 0 to m minus 1 and b equals to 0 to n minus 1, but it is always been better. That means, say we have to find like that, if this is the corresponding say input, and you have to find the neighbor of this particular pixels. So it is always been better that we place the kernel such that that particular pixels will be at the center of the kernel. That should be like that. That means if we want to find that, it will be always better that we place the kernel such that that particular thing will be at the middle of the at the middle of the kernel, like that, and that should be approximate. So the thing is, we have to place the kernel such that the pixel is at the center of the kernel. That should be the which pixels is of interest. So the formula actually we are using on the basis of this center. That means that formula, that's just we are changing the the variable. That means the value of a, that's not coming from minus m by 2, and for that is from m by 2, and for uh, b is that is also simple, minus n by 2 to that is n by 2, and that is also same thing, I minus a comma j minus b, and this is k m by 2 plus a n by 2 plus b, like that. So that is nothing but, in other words, we will assume that the kernel is centered on the pixel of interest. That is nothing but the meaning of, in other words, we will assume that the kernel is centered on the pixel of interest, center of pixel of interest, that we will get. So we will be looking at both preceding and succeeding neighbors, and I am not going details to the convolution, but if I have a time, then I can actually cover it, because by using these convolutions, whatever actually we did in Adobe Reader or Photoshop, that means you are sharpening the image, you are blurring the image, whatever be the thing you are doing, that is actually nothing but the convolutions. That means if you take an image, if we convolute it with respect to the filter, then we will get the corresponding blur figure, like that. It is happening. If you see that, if we take any image, and if we convolute it with this, if we convolute it with this, then the result figure, that is nothing but you will get the blurs the image, because you have to think of that. That means what you are doing, if we take any pixels from that, you are convoluting it with 111 and all those stuff. That means we are taking each pixels and doing average of each pixels. If we do that, the sharpness is gone and the image become blurred. So it is the intuitive thinking. That means we can do, that means if we change this the filter, we will see that we can create the sharpness of the image, we can detect the age of the image just by changing the just by changing this filter. And that is actually happening when we are doing Photoshop and Adobe. You will find that just by clicking the button, the image will be sharpening the image, blurring the image, or whatever be the thinking. That is nothing but you are convoluting over the images. So I am not going details on that, because we have not such time. So now the thing is that I am directly going to the attention mechanism, because we have to explain the corresponding mathematics behind that. So now the thing is that the first paper, actually the best paper from the machine attentions that you shown me, that is nothing but the attention mechanism with the help of machine translations, that we are dealing with machine translation, and that means semantic analysis or whatever with the thing. That means the thing is that that is attention, mechanism. The thing is that uh, we are motivating tasks of attention with with the help of machine translations. That the process is machine translations. And we know that you should know, because in the starting of the lecture what I told you, that before going to the attention network, it is always been better to cover the CNN, and after that encoder decoder, because the attentions network is nothing but it is the improved model of the encoder decoder thing. That means if we know the encoder model, if we consider about the encoder actually reads the sentences only once. The encoder actually read the sentences that only once. একবারই এনকোডার কি করে, পুরো সেন্টেন্সটাকে রিড করে, and then it actually encodes it. And so there are two options: either you have to pass the encode at 0th time step, you are just pass the encode, that means you are reading the corresponding sentence, and pass the encode at every time step. There are two, that means you are passing at the 0th time step, or you are passing at every time step. So each time step the decoder use this embedding to produce a new words, like that. But actually the human will not do that like that. বলো।
স্যার, বলছি আজকের এনকোডার ডিকোডার করবো না, ওই পেপারটা তো কনভলিউশন বেসড
না,
অ্যাটেনশন
এনকোডার
ওদের
ডিকোডার
উপর
আমি
দিয়ে।
যাচ্ছি না, আমি জাস্ট বেসিক জিনিসটা বুঝি, আমি এনকোডার ডিকোডারের ফর্মুলায় যাব না, ঠিক আছে।
ওকে।
দ্য ডিফারেন্স ইজ দ্যাট, লাইক দ্যাট, সেটা না বুঝলে তোমার ওটার ইন্টারেস্টটা থাকবে না অ্যাটেনশনে, বুঝতে পেরেছো।
ঠিক
এনকোডার
আছে।
ডিকোডার অ্যাকচুয়ালি কি করে, ইট উইল রিড দ্য এন্টায়ার সেন্টেন্স। এটা তুমি বলতে হবে, তুমি যখন এক্সপ্লেন করবে, তুমি যখন এই অ্যাটেনশনটা, তুমি তখন
হ্যাঁ।
এটা বলেই শুরু করবে, ইন কেস অফ এনকোডার ডিকোডার হোয়াট দ্য থিং ইজ হ্যাপেনিং। এনকোডার কি করে, পুরো এন্টায়ার সেন্টেন্সটাকে রিড করে, তাই তো, এবং
হ্যাঁ।
তাকে মনে রাখে, পুরো সেন্টেন্সটাকে মনে রাখে, এবং তারপরে তাকে ট্রান্সলেশন শুরু করে, বুঝতে পেরেছো। কিন্তু
হ্যাঁ
তুমি
স্যার।
ভেবে দেখো, আমরা তো তা করি না। আমরা যখন ধরো একটা যদি সেন্টেন্স 25 ওয়ার্ডের হয়, তাই তো, তুমি কি প্রথমে পুরো সেন্টেন্সটা রিড করে তারপর মানে খোঁজা শুরু করো? তাই তো আমরা শুরু করি না। বাট এনকোডার কিন্তু তাই করে, মানে পুরো সেন্টেন্সটা রিড করার পর মানে খোঁজা শুরু করে। এবার আমরা কি করি, ওয়ার্ড বাই ওয়ার্ড মানেটা খোঁজার চেষ্টা করি প্রথম থেকেই। কারণ আমাকে যদি বলা হয় ইউ হ্যাভ টু রিড দ্য 25 ওয়ার্ডস ইন এ সেন্টেন্স, তারপরে আমি মাথায় রাখবো এবং তারপরে আমি ট্রান্সলেট করা শুরু করলাম, আমি তো মধ্যেখানে অনেকগুলো ওয়ার্ড হারিয়ে যাবে না। ব্যাপারটা বুঝতে পারলেন? বুঝতে পেরেছো কি করতে বলতে
হ্যাঁ,
চাইছি?
বুঝেছি। হ্যাঁ।
এবং
হ্যাঁ।
দ্যাটস দ্য প্রবলেম অফ দ্য এনকোডিং অ্যান্ড ডিকোডিং। That means we are doing that for a sentence which has say 25 words, what you have to forget something, and you will lose some word during the translations. And not only that you have to, the entire sentence is important all that time. You have to encode all the sentence at same time. So only certain words, tara amra ki kori je only certain words are important. That means humans always try to produce each word in the output by focusing only on certain words in the input. So essentially at each time step what we come up with the distribution of the input words. That means actually what we are doing, we compute the probabilistic distribution which tells me which of the input word we need to focus on, and at that moment if it is okay, we don't know the translation for other things. That means what I am trying to say, you just see that particular figure, then it would be understandable. That's why the thing is that you just see that is the corresponding thing actually doing in the translations. That means the input that is given, that is I am going home. So that means when you give to the encoder, that means the total word will be putting there, and they will be translating it like a me ghar ja rahi hu. That is the Hindi words I am taking from some papers, that way. So at that moment we know, but when we are doing with the machine translations, that means we are doing with the attention network, we are not concentrating on the whole input, rather than we are concentrating on the particular words that is important to us. That means, say, what will happen, that means at that moment we don't know the translation for uh, what do you mean by ghar or ja, etc. As we know that the translation of may is done, we are not concentrating on the whole sentences. This is the word first we need to produce. That means what is the word we have to produce from I to main. So at this point, we just need attention to the first word of the input, and I can ignore everything else. And what about the second timestamp? In the second timestamp, we can focus on the last word. That means what is in the third timestamp. And what is in the third timestamp? So it is only necessary that we are only focused on one word at every timestamp. No, we can focus more than one. But the encoder decoder model is not doing like that. So the thing is, the main thing you just concentrate. So we need to learn to pay attention to certain words or the important parts of the sentences. And the distribution tells us how much attention we have to pay to each input word at each time step. So ideally, we know that at each time step, we would feed only this relevant information. That means encoding of relevant words to the decoder. So say, we can say that if we revisit the decoder, we have seen so far that either feed in the encoder information only once, either we have to feed some encoder information at each time step. And suppose there is an oracle, suppose there is an oracle actually told you which words to focus on at what time step. Let's say, that means that is not given, but I am taking that there is some oracle that will give you that at which time instant which words you have to focus. So say at time instance t, this going is very important at that time instant. And so that particular blue vector, that particular blue vector will be feed only. Now in certain instance, if we told that two words are important, so we are just concatenate them and feed into the network. That means at some time instance they will say that okay, going is important as well as home is important, so we are just passing these two, we are concentrating on these two vectors that will be passed to the decoder. But now it may be possible, that means we are concatenating this, because we are concatenate them, and we have to feed it into the network. How can you feed? You just see that line will be single line, you just say that will be the single line. That means that is not parallel. That means if we the two words are important, that means we have to concatenate these two things, and then the result will be passing through that. So the thing is that in that particular moment, if the four words are important, then you cannot concatenate, because the dimensions will may hamper. So we can feed weighted sum of the input. So that's why we have to feed the weighted sum of the input. So let at time instant 3, that za and this rahi at time instant 3, say that has value zero point 0.5, and that value as zero point 0.5. So we can do weighted sum, and then we can feed it to the input. So we know that the blue vector, has the same dimension, so the weighted combination of them will have the same dimension. What I am trying to say I am going to home. So this is important now. So at time instant t we are giving the weight 1000. That means input is made, that is a I am going to form like that. In say in next time instant, this say the last, if home is important, then we will give a time instant t that should be 1, and say a time instant sum t3, this ja and rehi that has a value 0.5 and 0.5, that is arbitrary, I am just taking this. So you know that the at time instant t the you maybe the void vector should be like that. So how you can feed it? We can feed it by using, you know, you can feed it by using the weighted sum of that. Weighted sum, that means we could just take the weighted average of the corresponding words representation, and that will be fed to the decoder. And for example, at time instant 3, you know, we can just take a weighted average of the representation of Ja and Rehi, and intuitively, you know, that model would work better because we are not overloading the decoder with irrelevant information. Because in case of encoder decoder model, we are just overloading whatever important thing or non-important thing, we are just overloading the whole sentences one time to the decoder. But in that particular case, we are firing only the blue vector of the important word. We are not loading the whole vector with the corresponding sentence. We are just, you know, fire this particular blue vector. So the thing is that, okay, up to this that is oracle, but of course in practice there is no such oracle which will tell you that, oh, that moment going is important, you feed it. At that moment home is important, you feed it. But that is not actually happening in the true practice. What will happening? The machine, you know, will have to learn, have to, you know, learn this, you know, from the data itself. Machine have to learn it from the data itself. And whenever you have to learn something, you need to introduce parameter. Why we are deriving the formula? I am coming here because whenever, you know, because this oracle, that means the oracle will tell you that going is important, that will never happen. That means your machine will have to learn this from data. And whenever, you know, you have to learn, whenever you have to learn something, what we know, you need, you know, you need to introduce parameter. You need to introduce parameter. You need to introduce parameter. So we are now going to introduce parametric from. So that's why we are, you know, now going to introduce, but we have to introduce parametric. We have to going to introduce the parametric from from you know, from the figure. So to enable this, we have to define a functions. We have to define a functions, and the functions is written like that: EJT, that is equals to, that is the attention functions, and this is st minus 1 aj. And what is this? What is EJT? It is nothing but at, you know, at t8 time step, at the t8 time step of the decoder, tm time state of the decoder, what I try to, I try to find out how important, how important is z word in the input. That is the main thing. That means we are giving attention to words. So actually what we are trying to find, that at some time instant, what, which word is important that we want to feed it, that EJT is calculated. That means, so you know, that should be depend on what, depend on what, that should be depend on what that the word is. That means aj is nothing but, you know, that is nothing but the words itself. And it depends on what could happen in the decoder so far, because if the decoder will already translate im, that should be known to me, that im is already been translated. That means that is the two functions that is dependent on one, that is hg. It depends on the words. Hj is nothing but, it depends what depends on what, that word depends on word, that words, and that is nothing but st minus 1. St minus 1 is nothing but on what could happen, in the decoder so far, in the decoder so far. So at every time step, instead of oracle that will giving the weights, I have to learn the weights, because we are not concentrating on the weights. So that means at every time instant, the oracle is not giving the weights. I have to learn the weight. And whenever we have to learn something, we have to introduce parametric form. When you have to learn something, you have to introduce parametric form. So several ways there is you can write the functions, but that is one of the way. So you just remember the thing, EJT is nothing but the quantity that captures the importance of the jth input word for decoding the tth output word, tth time instant. Another thing that we want, that across all the input words, EJT actually sum up to 1. EJT is actually sum up to 1. We don't want arbitrary weights. So what is the next possibility? That means you have to introduce, that means we have to convert it probability distributions if we have EJT, and we have to use the softmax, because we normalize the weights by using softmax functions. So the thing is that what I am writing the softmax function, so that means this is alpha zt is nothing but exp e of jt divided by, that is nothing but that the softmax functions, the summation of EJT. So alpha JT, what is this? It denotes the probability of focusing on the jth word to produce the tth output word. Alpha JT, that actually denotes the probability of focusing on the jth word to produce the tth output word. So we are now trying to learn alphas instead of an oracle that is informing to us. I have to learn the value of alpha, and learning would always involve some parameter. So we have to define a parametric form of alphas. That means now we will refer to the decoder, that is the recurrent neural network state of the tth time instant. If we just concentrating on the figure, you will say that is nothing but the alphas, that is nothing but the alphas that will come from that is a blue vector, that is nothing but ht, and this is the corresponding input you were given, that is the the ht value, and that is the corresponding alpha, and that will from now so you will refer to this decoder RNN state at the tth time instant as st, and encoder's RNN state as j time instant as az. So what I am concentrating, that the we are considering, we will refer to the decoder RNN's state at the tth timestamp as st, and encoder state at the jth time stamp as hj, because that is the hj and that is just st. That will be, I think, written in the next thing. That means that is nothing but st, and that is nothing but ht, you can say. So giving a new notations, the possible, now we are not, you just see, we are just giving the function, we just know that particular, that particular functions, that is the attention network, that is dependent on the previous decoder's value and as well as the inputs that will given, and that is nothing but we are concentrating on the which words are important, but we are not telling anything about FATT. So that that is a functions and there are many possible functions, but we are introducing some new notations. Just look carefully that you know that Z attentions. Why I am writing this, you will also you can also take tan h, that is the corresponding function, that is U attentions. One is the previous decoder and this is W attentions and HJ. And why we are writing that? So why we need this parameter like that? We are introducing the parameter VAT. This is a U attentions, that is W weight attentions, and what is the need of this? Now if we concentrating on the dimensions, what is the dimension of this? This is the dimension of a vector of d dimensions, and of course that Hj has also the same dimensions of Rd. So what we know that tan h portions, that should be a that is a vector, and this value is nothing but a scalar quantity. This value is nothing but a scalar quantity. That means you have to introduce this, because that tan portions, that will give a vector quantity, and that this is nothing but a scalar quantity. Then of course you have to introduce another vector such that if you can dot product of that, that will give you the scalar. So that's why you have to introduce this quantity. You have to introduce this quantity, and of course that has the same dimension as this, and weight it should be have the same dimension as this. That means that should be a vector and this is a scalar. So you have to dot product with some vector such that we will get the scalar, and that's why we have to introduce that amount of the quantity. So here this V attention is nothing but also the same dimensions are Rd. B U attentions, that is also as the same dimension of R D cross D, and W is also we have to introduce this particular vector, that is also matrix like that. We have to introduce this, that is the additional parameter additional parameter of the corresponding model, and this parameter will be learned along with the other parameter of the encoder and decoder model. So if we see the diagram, you can say that is a that is a map. If the task is machine translation, the data xi is a source, that is a x1 x2 x3, that is the source, and that is the output is the target. The encoder is using RNN, and that will take h and xi, and output is st, and if we want to decode, and decode will you have to find which words it should be importance, and that will be found with the equations that we write, where alpha ij can be found by the softmax of this, and that would be finding by this value. That means this is the previous decoder RNN. We are giving the input, that is st minus 1, and what is c is nothing but the weighted sum of this, and that will be fed as a decoder, and that we will get as a, this is a bias, you can take it as that. So that is the chorus parameters, and loss and actually algorithm, that are the same as the encoder decoder model. So you just know that is the corresponding equations, and the equations will come like that. We are feeding the alpha, that will be go, and that will be in decoding part, that will be the result will be the important words that we want to fetch. So the thing is that is the, now the questions it may come that that is the attention, that is we are using this is for machine translation or semantic analysis, whatever be the thing, that is the part is similar. And one thing you can refer at that particular model, you can see that That is the one of the paper, that means that is the example of the output of attention based summarization, that is a corresponding paper, and that is the attention based neural machine translation model. And you will see from the figure, that is hazy but still try to see that that is the corresponding, the words and the corresponding, that particular, say, you know mm, it may be something, so that means what I am saying, that if this particular words with matching with particular context, you will say that is a deeper, that's a heat map, that will be deeper line. That means the words which are important, we can find it by that. That means that particular word, whatever be the thing, that will be matches with this. So that's why at that particular thing, that will be, more deeper. And with this word, the next word will be matches less than that. So that's why that is less deep, like that. So this is the number of words, and we are making some parameter, we are making translations, and what we can find, that word should be matches with this, and that's why this value is greater. Now if the same thing will be done by using, that is the conversions from the English and to the French, say this is the, the French word, and this is the corresponding, say, English word. Now what will happen, the almost the French word, that means like that, in case of Bengali also, I am going, like that. And the thing is, আমি like বাড়ি বা whatever the. Now the thing is, if this I will be matches with আমি, am will be matching with something, going will be matches with something. So what will happen? The all the value, that maximum value will lies in the diagonal, because this I will be matching with I, this value will be matching with this value will be matching with this value. That means all the value that lies on the diagonal. That is the one of the example where you can say, uh, if we translate with one language to another language and which are similar to that, that means in that case the maximum values are lies on the diagonal. And in that particular case you will find when this particular, that means if we say terrorism, that words that will matches with which words, that means if it matches, that means the corresponding word which matches with the terrorism, that means actually deeply recognized by the hitman. So that is the two papers where they use the attentions model, and you can, I think, it would be easily understandable. So the thing is that uh, uh, that is the thing, and you can apply the attention also in case of images also. In case of images, that means how do you we model an attention in images. And in that particular case of text, what we know, we have a representation for every locations of the input sequence, because every sequence has some locations. But now the thing is that if we consider about this image, what we have to do, we have to put in the whole image in CNN, and then we will get this blue vector. That's the normal procedure. But the thing is, in attentions network, we are not trying to feed all the images. We are trying to feed the importance part of the, images. So how do you model an attentions mechanism for images? And of course, in that particular case of text, we have a representations for every location of the input sequence. But for images, we typically use, representation from one of the fully connected layer. That means your image does not give any location information, because that particular locations informations we have to read. So in that particular case, if we use the convolution neural network, that is a layer, and like that, and the problem will occur at that particular layer. That means that is a densely connected layer, and you don't have any, the location information. That means we have to extract the particular attentions, and so that is written here. That means, that is VGG net is used, and 14 14 512 size features map that is used. We are applying softmax. So I'm not going details for today, but the thing is that what I trying to say, that in that particular case, how the particular locations will be treated, and what should be the dimensions that we take, and how your model will learn and attentions, like that we can break it into different parts, and that can be written as h1 to h96, and then you have to fade it like that. So the image can be fade also, by the convolution. Then that can be used, uh, uh, for a better purpose. So here also, the model will learn and attentions of these locations by using the same, the parameter that we consider. And also, we can say that can be used in several purpose, in context. And if this is a response, that means, can we suggest a good movie? Yes, sure. How about the Logan? And okay, who is the lead actor? And from that particular context, we have to find the responses. We want to get the responses. So how can we do that? We can also do that by using the attention network. That also can be done about the attention network. So that is also the same thing. That means we can fade it into, and then we will get it like that. But before that, actually, that's why I'm telling you that you have to concentrate on RNN or CNN, if you want to understand all the things. But the basic thing, I know, I think it is now clear to all of you.